Hey, it's Stack Lessons. I read the docs on network security, Shield, WAF, Firewall Manager, security groups versus NACLs, so you don't have to. Here's the part that actually matters. By the end of this video, you'll know exactly which Amazon Web Services network security control stops which kind of attack, and why picking the wrong layer lets the attack walk straight through. We're covering Shield, WAF, Firewall Manager, security groups, and network ACLs, 5 tools, 1 decision rule. Quick recap before we dive in. Episode 7 drew the line between Amazon Web Services responsibilities and yours. Episode 10 set up Code Gorilla's 40 client accounts inside Control Tower. And Episode 11 covered the services that detect threats and surface findings. Today we shift from detection to actual prevention, the controls that stop traffic before it reaches your application. 5 terms to anchor this episode. Amazon Web Services Shield is Managed Distributed Denial of Service, DDoS, protection at the network layer. Amazon Web Services WAF is the Layer 7 web application firewall that inspects HTTP traffic. Amazon Web Services Firewall Manager is the central service that applies all of this across every account in your organization. A security group is an instance-level, stateful firewall that allows traffic, and a network ACL is a subnet-level, stateless firewall that allows or denies traffic. Hold on to stateful versus stateless and allow only versus allow and deny. Those two pairs will guide every decision you make about network security controls. Here's the scenario we'll come back to throughout the episode. It's midnight, and Code Gorilla's retail client kicks off a flash promotion. Within 5 minutes, login attempts spike 400 times their baseline. These aren't shoppers, these are credentials leaked from other breaches being replayed against the login endpoint. The on-call engineer pulls up the console and asks the only question that matters: at which layer do we block this? The load balancer? The instance? The subnet? The edge? Because if you pick the wrong layer, the control you reach for can't even see the attack. Keep this scenario in mind. We'll resolve it once you have the full picture. Picture the path a request takes from an attacker to one of your instances. First, it hits Shield at the Amazon Web Services edge, where volumetric floods get absorbed at the network and transport layers. Then it hits WAF, which reads the actual HTTP request and decides whether the payload looks malicious. If both let it through, it enters your VPC, the network ACL gates the subnet, and finally, the security group gates the network interface on the instance itself. 4 checkpoints, each looking at something the others can't see. Skip one, and the attack walks past your defense. Think of it like an airport. Shield is the perimeter fence. It stops a stampede before anyone gets near the terminal. WAF is the TSA officer reading what's inside your bag, which here means the HTTP payload. The network ACL is the no-fly list checked at the front door of the subnet, and the security group is the boarding pass scanner at the gate, right at each instance. You need all 4 because each one catches what the others can't. Let's start with Shield. Shield is Amazon Web Services managed DDoS protection, and it lives at the edge, meaning attack traffic gets absorbed long before it reaches your VPC. It operates at layers 3 and 4, which is networking speak for raw network and transport packets, so it's defending against floods of SYN packets, UDP reflection attacks, amplification, the volumetric stuff that just tries to overwhelm your pipes. There are 2 tiers: Standard, which is free and automatic, and Advanced, which is a paid subscription with a much bigger feature set. Let's look at each. Here's the part that surprises people. Shield Standard is already protecting your account right now. You didn't enable it, you didn't pay for it, you didn't tick a box during sign-up. Every Amazon Web Services account gets it automatically, for free, the moment the account exists. So when a scenario describes basic DDoS protection that's already in place with no configuration, the answer is Shield Standard, not because you subscribed, but because you can't not have it. Here's Amazon Web Services' own description. Shield Standard defends against the most common, frequently occurring network and transport layer DDoS attacks to maximize availability. 2 words to anchor on: common and frequent. Standard handles the everyday floods. What it doesn't handle is sophisticated application layer attacks, and it doesn't give you a phone number to call when something gets through. For those, you need advanced. Side by side, Standard is free, always on. Layer 3 and 4 only, no support team, no cost protection. Advanced costs $3,000 a month per organization, requires a 1-year commitment, and gives you 3 big things Standard doesn't. First, it adds cost protection, which refunds the scaling charges that a DDoS would otherwise leave you with when your auto-scaling group expanded to absorb the flood. Second, it extends DDoS protection to Layer 7. And third, it gives you 24/7 access to the Shield Response Team. That's a group of Amazon Web Services engineers you can call during an active attack. 3 capabilities are exclusive to Shield Advanced: the Shield Response Team, which gives you 24/7 expert support during an active attack; cost protection, which reimburses you for scaling charges caused by an attack; and Layer 7 DDoS mitigation, which handles application layer floods that Standard can't see. Any workload that requires one of these 3 needs the advanced tier. Standard simply does not include them. But don't recommend advanced for every workload. It's $3,000 a month plus data transfer fees, and it's a 1-year commitment. You can't try it for a month and walk away. There's also a catch on the response team. To actually call the SRT, you need a business or enterprise support plan on top of the advanced subscription. So the rule is, advanced makes sense when downtime would cost more than the subscription, a revenue-generating production app, for example. For a small internal tool, Standard is the right answer. Now WAF, where Shield sees raw packets, WAF sees the actual HTTP request. It can read the source IP, the headers, the URI, the request body, and it can track the rate at which a single IP is making requests. That gives it the power to block SQL injection attempts, cross-site scripting payloads, scrapers, bots, and credential stuffing. WAF doesn't sit alone. It attaches to a fronting service. CloudFront, an application load balancer, API gateway, app sync, app runner, and Cognito are the supported attach points. Here's Amazon Web Services' positioning statement. WAF helps protect against common web exploits and bots that can affect availability, compromise security, or consume excessive resources. 3 things to notice: web exploits, bots, and resource consumption. That last one is why rate-based rules matter. Even legitimate-looking HTTP can be malicious if it arrives 1,000 times a second from the same source. The attach points matter. WAF supports CloudFront, Application Load Balancer, API Gateway, App Sync, App Runner, and Cognito. What it does not support is attaching directly to EC2, and it does not support the Network Load Balancer. Why? Because the NLB operates at Layer 4, there's no HTTP for WAF to inspect at that layer. So if a scenario asks how to protect an NLB with WAF, the premise is wrong. One more deployment note. When you attach AWAF Web Access Control List to CloudFront, you must create it in US East 1, because CloudFront is a global service that's administered out of that region. You don't have to write SQL injection rules by hand. Amazon Web Services maintains a library of managed rule groups that update automatically as new attack patterns appear. The core rule set covers common high-risk vulnerabilities from the Open Web Application Security Project, OWASP, top 10 with 1 click. Bot control blocks scrapers and scanners, and account takeover prevention, ATP, is purpose-built for defending login endpoints against credential stuffing. That last one is the headline feature for the retail client we opened with. Pair ATP with a rate-based rule and you've got real defense. A rate-based rule counts requests per source IP over a rolling 5-minute window. Scope it down to the login URI. Set a threshold, say 100 attempts per IP per 5 minutes, and when an attacker crosses it, that IP is blocked automatically. Rotating proxies can still try to slip under per IP thresholds, which is why you layer ATP on top to catch the behavioral patterns rate alone can't. This isn't theoretical. Between 2015 and 2018, attackers used passwords leaked from other breaches against Dunkin' Donuts DD Perks loyalty accounts. Tens of thousands of accounts were compromised, stored value cards were drained, and Dunkin' ended up settling with the New York Attorney General. The defense was a rate-based rule on the login endpoint plus ATP managed rules, exactly the pattern our retail client should deploy tonight. Quick checkpoint. Shield handles volumetric DDoS at the edge, with Standard always on for free and Advanced adding Layer 7 protection, the response team, and cost protection. WAF inspects HTTP semantics, payloads, URIs, headers, and request rate. Now 2 scenarios remain. How do we apply these everywhere at once across an entire organization? And what happens once traffic actually gets inside the VPC? That's Firewall Manager, security groups, and network ACLs. Firewall Manager is the central control plane. From a single security admin account, you can push WAF rule sets, Shield advanced protections, and even baseline security group configurations to every account in your organization. It also covers network firewall and Route 53 resolver DNS firewall. The best part is auto-enrollment. When a new account joins the organization, or a new ALB gets created, the policies apply automatically. The prerequisite is straightforward. Amazon Web Services organizations must be enabled with all features. Amazon Web Services' own one-line definition. Firewall Manager lets you create, configure, and maintain firewalls with common security policies across accounts and VPCs in your Amazon Web Services organization structure. The phrase across accounts is the giveaway. If a scenario describes a security policy that must apply uniformly across an entire organization, Firewall Manager is the answer. Think of it as corporate headquarters. If each Amazon Web Services account is a franchise store, Firewall Manager is the security manual every store must follow. Open a new franchise, and the manual ships with it. Try to ignore a rule, and headquarters gets an alert. Without this central control, every account team writes their own rules and you end up with the inconsistency problem Code Gorillas already has. Connect this to Code Gorillas. From episode 10, all 40 client accounts now sit inside Control Tower. Layer Firewall Manager on top and you can declare a single policy. Every public-facing application load balancer in any client account must attach the Amazon Web Services managed common rule set. When Account Factory vends a new client account, it inherits the policy on day one. This is exactly the fix for the inconsistency problem we saw with S3 public access settings, but for network security. Now we move inside the VPC. The security group is a virtual firewall attached to an instance's network interface. 4 properties to memorize. It's stateful, meaning if a flow is allowed in, the reply going back out is automatically permitted. It supports allow rules only. There is no deny option, full stop. The default behavior denies all inbound traffic and allows all outbound. And one instance can have multiple security groups attached at once. These 4 properties are the foundation of every security group decision you will make. Here's the way to remember stateful. A security group is a doorman with a memory. He sees you walk in, makes a mental note, and when you turn around to leave, he just opens the door. no second check required. That's why you only ever write one direction of rule for a flow, and the reply just works. You don't need a matching outbound rule for the response packets. Here's the property that makes security groups uniquely powerful. They can reference other security groups as a source. Look at the three-tier pattern. The ALB security group accepts port 443 from anywhere on the public internet. The app tier accepts port 8080, but only from the ALB security group, no IP range, just a group reference. And the database accepts port 5432, only from the app security group. Now auto-scaling can spin app instances up and down all day. Each new instance joins the app security group, and the database automatically permits it. Zero rule changes, ever. Think of it as a badge instead of an address. You're not telling the database to allow IP 10.0.1.5. You're telling it to allow anyone wearing the app tier badge. Whoever gets handed that badge is in automatically. This is what network ACLs cannot do. They only understand classless inter-domain routing, CIDR, blocks, raw IP ranges. Security group referencing is identity-based, and it's the production default for any dynamic environment. Now network ACLs. The network ACL is attached to a subnet, not an instance, so it protects every interface inside that subnet collectively. It's stateless, meaning every packet is evaluated independently in each direction. It supports both allow and deny rules. That's the headline difference from a security group. And rules are evaluated in numeric order, with the first match winning. One subnet has exactly one network ACL attached to it. If a security group is a doorman with a memory, a network ACL is a doorman with amnesia. Every time you walk through the door, even just to leave, he asks for your pass again. That means for any flow you want to work, you have to write both the inbound rule and a matching outbound rule. And for return traffic, that outbound rule needs to cover the ephemeral port range, typically 1024 through 65535, or replies just get dropped silently. This is the most common production mistake with custom network ACLs. Here's how evaluation walks the rule list. A packet arrives. Rule 10 says deny that specific malicious IP. If it matches, the packet is dropped and evaluation stops. First match wins. If it doesn't match, we move to Rule 100, which allows port 443 from anywhere. Then Rule 110, allowing port 80. And finally the implicit deny at the end, which drops anything no explicit rule allowed. Numbers matter. They decide the order of evaluation. NACLs evaluate rules in numeric order, and the first match wins. So if you put allow everything at Rule 100 and then add a deny for a specific malicious IP at Rule 110, that deny never runs. The allow at 100 matched first, the packet was already permitted, and evaluation stopped. To make the deny effective, give it a lower rule number than the allow it conflicts with. The practical habit is simple. Number your specific deny rules first, then your broader allows. This ordering rule comes up regularly in scenario questions. Side by side, the differences that matter. Security groups are instance level. Network ACLs are subnet level. Security groups are stateful. Network ACLs are stateless. Security groups allow only. Network ACLs allow and deny. Default security group denies inbound and allows outbound. Default network ACL allows everything both ways, and security groups can reference other security groups. Network ACLs only understand CIDR blocks. These two properties, statefulness and deny capability, determine which control to reach for in any subnet or instance protection decision. Straight from the VPC documentation. Security groups are stateful, which means return traffic is allowed regardless of the rules. Network ACLs are stateless, which means return traffic must be explicitly allowed by the rules. There's no ambiguity, No edge case. That's the rule, in Amazon Web Services' own words. Here's the scenario that catches engineers in their first month on Amazon Web Services, and it illustrates exactly why the two controls exist side by side. An operator sees 200 secure shell (SSH) probes from a single IP address. First instinct: open the security group and add a deny rule. But security groups don't have deny rules. There's no such option in the console. No syntax for it in the API. Allow only means allow only. The fix is a deny rule on the subnet's network ACL. Rule number 10, action deny, source the offending IP as a /32C IDR done. And here's Amazon Web Services' own answer in the knowledge base. To allow or block specific IP addresses for your EC2 instances, use a network access control list, not a security group. The wording is intentional. Amazon Web Services knows this is the confusion, and the documentation settles it directly. This table is the entire decision tree. Volumetric DDoS goes to Shield, SQL injection, cross-site scripting, bots, credential stuffing all go to WAF. Allowing traffic to a specific instance or tier goes to the security group. Denying a specific malicious IP at the subnet goes to the network ACL, and applying any of these centrally across every account in your organization goes to Firewall Manager. 5 lines. If you can match the threat to the service without thinking, you can resolve any network security decision in seconds. 4 mistakes worth unlearning right now. First, trying to block an IP with a security group. Security groups can't deny, only network ACLs can. Second, forgetting the ephemeral port outbound rule on a stateless network ACL, which makes replies vanish into the void. Third, numbering deny rules higher than the allow rules they're meant to override, which makes them dead code. And fourth, recommending Shield Advanced for a small workload when Shield Standard is already on, already free, and already absorbing the everyday floods. Back to the credential stuffing attack we opened with. Credential stuffing is a Layer 7 attack. These are real-looking login requests, not a packet flood, so Shield won't catch it. This is WAF's territory. Deploy a rate-based rule scoped to the login URI, layered with the account takeover prevention managed rule group. Then push that policy through Firewall Manager so every other Code Gorilla's client account inherits the same defense, not just the one being attacked tonight. And in the background, Shield Standard is still absorbing any volumetric component at the edge, for free, with nothing to enable. Make this your reflex. Identify the layer first. The layer picks the service picks the specific rule. Volumetric flood at layer 3 or 4. Shield. Malicious HTTP at layer 7. WAF traffic gating at an instance or tier. Security group. Denying a specific source at a subnet. Network ACL layer first, every time. 5 things to take with you. Shield Standard is free and automatic for every account. Advanced adds Layer 7 protection, the Shield Response Team, and cost protection. WAF inspects HTTP at Layer 7 and attaches to CloudFront, ALB, and API Gateway, not to NLB or directly to EC2. Firewall Manager applies WAF rules, Shield Advanced, and security group baselines across every account in your organization. Security groups are stateful, allow only, instance level, and can reference other security groups. And network ACLs are stateless, support both allow and deny, sit at the subnet level, and are the only place inside the VPC where you can block a specific IP. Now let's see how well that landed with a quick 5-question quiz. Question 1. A security engineer notices repeated SSH probes from a single malicious IP address targeting EC2 instances in a public subnet. They want to block this specific IP from reaching anything in that subnet. Which Amazon Web Services control should they configure? A. Add a deny rule to the network ACL on the subnet, with a low rule number. B. Add a deny rule to the security group attached to each EC2 instance. C. Create a WAF IP match rule and attach the web access control list directly to the EC2 instances. Or D. Create a WAF web access control list with an IP block rule and attach it to the EC2 instances. Pause here if you want more time. The right call here is A. Network ACLs are the only VPC control that supports deny, and the low rule number is critical so the deny fires before any conflicting allow rule. Option B is wrong because security groups don't have deny rules at all, only allow. And both C and D are distractors because WAF cannot attach directly to EC2 instances. It only attaches to CloudFront, application load balancers, API gateway, and a handful of other supported resources. Question 2. A company runs a revenue-generating e-commerce site fronted by CloudFront and an application load balancer. They want 24/7 expert support during DDoS attacks and reimbursement for scaling charges caused by an attack. Which service meets these requirements? A. Shield Standard. B. WAF with the core rule set. C. Shield Advanced. Or D. Firewall Manager. Lock in your answer before I give it away. This one is C. Shield Advanced. Two phrases in the scenario pin it down. 24/7 expert support means the Shield Response Team, and reimbursement for scaling charges is DDoS cost protection. Both are advanced-only features. Standard is free and automatic but offers neither. Question 3. An e-commerce site is being hit with credential-stuffing attacks against the login endpoint during a promotion. Attackers replay leaked passwords from other breaches. Which combination most directly mitigates this attack? A. Shield Standard plus a stricter network ACL on the subnet. B. Shield Advanced with the Shield Response Team engaged. C. A network ACL deny rule on the subnet combined with Shield Standard at the edge. Or D. A WAF rate-based rule scoped to the login URI plus the account takeover prevention managed rule group. Think about which layer the attack actually targets. If you said D, well done. Credential stuffing is a layer 7 attack. These are real-looking HTTP login requests, not a packet flood, so Shield can't see them. WAF can. A rate-based rule throttles per IP attempts on the login endpoint, and the account takeover prevention rule group catches the behavioral patterns that rate alone misses. Options A and C lean on layer 3 and 4 controls that have no visibility into the login payload. Question 4. A consultancy manages 40 Amazon Web Services accounts in a single organization. The security team wants every public-facing application load balancer in every account, including new accounts created in the future, to automatically have the Amazon Web Services managed common rules set attached. Which service should they use? A. WAF deployed individually in each account. B. Shield Advanced with cross-account protection. C. Firewall Manager with AWAF policy at the organization root. Or D. Config rules deployed via CloudFormation stack sets. Got your pick? Let's see. The right call is C. Firewall Manager. It's the only service that centrally enforces WAF rules across every account in an organization and auto-enrolls new accounts and new resources as they appear. Option A leaves you managing 40 separate WAF configurations by hand, and drift becomes inevitable. Option D might detect non-compliance, but it doesn't push the WAF rule itself. Question 5. And this one is a callback to Episode 7. Under the Amazon Web Services shared responsibility model, who is responsible for configuring security group rules on an EC2 instance to restrict inbound traffic? A. Amazon Web Services, because security groups are part of the VPC infrastructure. B. The customer, Because guest OS and network configuration are security in the cloud. C. Amazon Web Services, because Shield Standard automatically configures all VPC firewalls. Or D. Shared between Amazon Web Services and the customer, with Amazon Web Services setting the defaults. Run the decision rule from episode 7 before you answer. The answer is B. Security group rules are part of security in the cloud, the customer side of the shared responsibility model. Amazon Web Services provides the security group as a feature, but you are fully responsible for what rules you write into it. A misconfigured security group that exposes a database to the internet is a customer failure, not an Amazon Web Services one. Okay, network security, Shield, WAF, Firewall Manager, security groups versus NACLs, done. If today's quiz caught you out, that's a good thing. Better here than on exam day. See you in the next video.